Okay, so in this lesson, we're going to be looking at another tool that we can use to help us solve for triangles, lengths, and angles. In the last lesson, we learned that in any triangle, if we have three measurements, and if this given information completes one of the ratios for the law of sines, then we can use the law of sines to find all the other missing measurements. So then the question comes up is, well, what if I don't have that information? What if I don't have the information that completes one of the ratios for law of sines? What can I do then? Well, as the title suggests, we have a law of cosines. Okay? The law of cosines, if you look at the note real quick, is really just an extension of the Pythagorean theorem. Remember, the Pythagorean theorem starts off by saying, in a right triangle. So, if I don't have a right triangle, this is the extension of the Pythagorean theorem, because if you look at it, you can see right there, right? A squared plus b squared is c squared. That's the Pythagorean theorem. But because this is not a right triangle, then this little piece here comes up into play. And the reason why this is an extension is because if the central angle or some angle is 90 degrees, the cosine of 90 degrees is equal to 0. So this whole entire term disappears. The law of sines, if you remember, kind of uses the concept from geometry of angle, angle, side, or side, side, angle. The law of cosines uses side, angle, side, or side, side, side. So if I have only the three side measurements, I can use law of cosines to help me find angles. If I have side, angle, side, the angle in between another side, then I can use law of cosines to find the other pieces that are missing. The three forms that you see here, they're basically the same form, just from a different angle point of view. Okay? And notice that this side out here that's squared is the same as the angle that you're taking the cosine with. And the other two measurements are the other two sides. Notice the pattern that's here. So the two other sides are squared, you add those and you subtract this quantity right here. So the pattern is pretty simple, easy to remember, and you just use it accordingly. So the side that's out here is the one that is opposite this angle. So that's the key to this process. Okay? So let's look at some examples on how to do and use the law of cosines. In this paper over here, I'm going to write a version of it. So a squared is b squared plus c squared minus 2bc times the cosine of angle A. So we'll use that as a guide to help us with the pieces that are missing. So here we go. What is the length of DE? So what is that length right there? That's what I'm looking for. Well, I have an angle. I can see clearly I don't have a complete ratio. So then I look to the law of sines, law of cosines, and I have a side, the angle, and a side. So I know I can use law of cosines. So this measurement over here, we can use lowercase f, since the angle name is f. We can say this is little f, right? And then we can solve this for that. So according to our rule here, f squared would be equal to 8 squared plus 6 squared minus 2 times 8 times 6 times the cosine of the angle, 62 degrees. So when you're writing this out, this is what I want to see. These angles, these sides can also be in parentheses. That would be kind of nice. So here's what you want to write. You want to definitely make sure you write that step right there. The next part is just you figuring this out. Since this is f squared, f is just the square root of this. Okay? And so then you can just use the calculator to figure that out. So don't forget to do the square root. So as you type it in, the square root of 8 squared plus 6 squared minus 2 times 8 times 6 times the cosine of 62 degrees. So once I have that, make sure it's all under the radical, which this is. Control Enter, and there's our response right there. You should round your answers to 3 decimal places unless they say otherwise. So we have over here a length of 7.412. And that's all you really need to do there. Okay, let's go look at this one over here. Same concept. Notice clearly that this is also a side angle side. This one right here is an obtuse angle. It doesn't matter. The process is exactly the same. So I have j squared is 12 squared plus 18 squared. 2 times 12 times 18 times the cosine of the angle between them, 110 degrees. Same process as this one over here. We just take the square root of both sides, and we get j is going to be approximately, so it should be approximately, and then we type it in. So the biggest mistake people do with this is they forget to take the square root, so be careful. Square root of, and then you just type it in, 18 squared minus 2 times 12 times 18 times the cosine of 110. And there you go, 24,814. Okay, very straightforward. Over here, how do I do and find angles? So again, I have no angles given. I have 3 sides, so that's side, side, side. So again, this is a candidate for law of cosines. So we just pick one of our angles that we're looking for, and we use our formula, and we go through this process. So let's start with angle x right here. If this is the angle I'm looking for, then this is the side that has to go on the outside. So we have to put 4 squared outside, and then the other 2 sides inside, so 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of angle x. So that's what you need to write. Okay, so if our unknown is over here, we have to move everything else to get it on the one side. So I'm going to subtract these 2 quantities, and then I'm going to divide by this number in front of the cosine. And that gives me the cosine of x equals 4 squared minus 6 squared minus 7 squared negative 2 times 6 times 7. Now the next part of this is I have to get x. So just like we learned the other day, to get to the angle in here, I have to use the cosine inverse. So if I take the cosine inverse of both sides, then x will equal the cosine inverse of all of this. And so this is what you need to write. So in this process, I'm looking for that line, and I'm looking for that line right there. Once I have this line right here, I can find the measurement of angle x by simply typing this into the calculator. So we type in the cosine inverse. We use the fraction line, 4 squared minus 6 squared minus 7 squared over negative 2 times 6 times 7. So just double check that, make sure it's all typed in properly with the right signs, and then hit Control Enter, and there is the measurement of angle x. Okay. Now it asks us to find the measure of angle y. So at this point, I have a decision to make. I can use law of cosines again, and this is probably the best way to do it and my recommended method. But sometimes you can also, since I have this angle right here, I have now completed a ratio. So you can actually go through and use the law of sines for this. Just be careful if you're using the law of sines. Because you rounded this off, if you use this number with 3 decimal places in your answer or in your next problem, you're going to get a rounding error. Okay? Possibly. So you could get the wrong answer from any textbook or answer key or whatever because you're using found information to find another piece of information. And your found information you have rounded off. If you use this, I recommend that you use the value in the calculator to at least 6 or 7 decimal places instead of just 3. So don't use this number. Use this if you can, the whole thing, or at least use it taking out to 6 or 7 decimal places, 0, 3. If I do that number right there, I should avoid any rounding errors in the next problem. Or I can just simply do the same thing again with angle y. And use the given information to find y. That is usually the best method, although not necessarily always the quickest. If I'm going to go from angle y, then I would just set it up as 6 squared equals 4 squared plus 7 squared, 2 times 4 times 7 times the cosine of angle y. And we just do the same process that we did here. Because you'll get used to this and go so fast, we can find y directly as the cosine inverse of 6 squared minus 4 squared minus 7 squared, negative 2 times 4 times 7. And we can type that in and get an approximate answer for that. Clear there. And so cosine inverse fraction, and then we have 6 squared minus 4 squared minus 7 squared. Negative 2 times 4 times 7. And there we go. 811. And so that's probably the best way to do it to avoid any kind of rounding errors. If you don't want to get an answer wrong because you did all the work right, but you have an error in this over here. Okay? So there's those problems right there. Let's continue on with some other ones. Here's a problem back here where we're solving the triangle. So again, remember, solving the triangle means we need to find all the other missing pieces. That means we got to find angle B, angle C, and side A. And from this, we can see clearly that I do not have a complete ratio, so I need to start off with the law of cosines. Okay? So over here, law of cosines, I need to find that side. So A squared is 26 squared plus 44 squared minus 2 times 26 times 44 times the cosine of the angle between, which is 69 degrees. And so A is the square root of all this, and so A is approximately equal to, and we can type this in. 26 squared minus 2 times 26 times 44 times the cosine of 69 degrees. Double check, make sure it's all the same. It's good. Oh, and you see what I just did? What did I forget? See how easy it is? I forgot to do the square root. Now, if you forget to do the square root, you don't need to retype the whole thing. Let me show you something. You hit Control and the square root button. So there's my square root. This calculator automatically saves the last answer in this button here called Answer, A-N-S. It's like a roaming, it's like a ever-changing variable box that has a value in there. Every time you get an answer, this number changes. So right now, A-N-S is this number. So all I have to do is just put that A-N-S in there. Like this. Let's get the glare out of there. So by doing the square root of answer, this number is answer. So I'm taking the square root of that. Okay? And that saves you a little bit of trouble if you forget to do that. Just be very careful. Make sure your numbers are reasonable. I knew that I made the mistake here, not because, because this number is so large. 1,792, when these other side lengths are these, okay, we know something was wrong. So take the square root of that. A little bit more reasonable, 42.333. So there is A. Oops. So there is A. Now, this time, again, I can go back through and I can find angles by using law of cosines again, which is the preferred methodology of doing so. Okay? But you can also use the law of sines. Again, remember, keep this number in there. Remember, this number is also stored now as answer. Answer has now changed to this answer because this is the most recent answer. If you leave it in there, you can use it in your calculations. Let me show you. So we're going to go next. We're going to do law of cosines. Law of sines. I have this side length, in that angle, so that's my completed ratio. And we pick another one of these angles to use. Let's go ahead and find B. We're going to find that angle right there. So according to the law of sines, I can go the sine of 69 degrees over this, and I'll just put 42333 as a reminder that it's this answer. And I know that the sine of B to 44. So doing all our stuff we learned last time for law of cosines, multiply the diagonal, divide by the third number. I know that the sine of angle B is 44 times the sine of 69 degrees divided by this 42333 number. Taking the sine inverse of both sides. So B is going to be the sine inverse of this fraction, 2.333. And I need to type this in a calculator. Okay, so let's do that. Let me show you how I would type it in to get the best answer. So I would type in, clear out of there. So the sine inverse, and then the fraction, and I have 44 times the sine of 69 degrees over, now instead of typing in 42333, I can just type this number that I'm looking at. But remember, that number, since it's the last answer the calculator produced, it is stored as answer, so all I have to do is just simply type in that answer. Just like that. Hit control and that A and S button. And that number is now sitting right there. And you don't have to type it in. Hit control enter, and there's your answer for angle B. And then you can just round this off your 3 decimal places. 0, 1, 3 degrees. Now, I'm going to show you something because I did this problem where I used this number exactly as it, just like this. I just typed it in just like this. And then I showed you how I typed it in with the full and complete answer over here, and we got this answer. This is going to illustrate to you why you get that little error. See, if I just use this, this is the answer that you would get for B. Okay, so when I typed it in originally in my notes, this right here, I used this number. I did not round it off, and look at the answer, 76.011. 76.013. So just note that that's going to happen. If you use rounded off or found information, you run the risk of a rounding error. Okay? So it just depends on the situation and what you're doing. So try to avoid it as much as possible. And we can get good answers. Once you have this written out over here, to find C, we just simply subtract the two angles from 180. And because they're all angles of a triangle, and then angle C pops off right there. Okay? So there you go. That is the law of cosines, and we will do more problems together in class.